Welcome to the course Sustainable Energy Management and Efficiency for Data Centers. In this first lesson, we introduce the concept of data centers, what they are, what they do, and why their energy footprint is so important. Many of our daily digital activities, from sending emails to using apps or storing files in the cloud, are supported by data centers. Though not visible, they are essential for the functioning of most online services. So, what exactly is a data center? A data center is a facility that centralizes an organization's IT operations and equipment. It houses computer systems that store, process, and transmit digital information. It typically includes servers, storage systems, networking hardware, and the supporting infrastructure needed to operate them reliably. The core components of a data center are arranged in racks, metal frames that hold and organize IT equipment vertically. Racks are typically laid out in rows to optimize airflow and space utilization, and to facilitate efficient cooling. These design principles are essential because servers generate heat continuously during operations and need consistent environmental conditions to avoid failure. Data centers are designed for continuous operations, 24 hours a day, all year round. This is necessary to ensure uninterrupted access to digital services, which can be critical for businesses and society. As a result, they consume electricity constantly, contributing to a steady baseload demand on the power grid. Data centers are not all the same. They can vary significantly in size, design, and purpose. Let's look at the three main categories. Enterprise data centers are built and managed by individual organizations for their own use. They are often smaller and less efficient. In 2005, they made up for the 85% of capacity, while today their share has fallen to just the 28%, reflecting a shift towards more scalable and efficient models. Colocation and service provider data centers rent out space and sometimes equipment to multiple customers. These are larger, more efficient, and they represent about the 36% of global capacity. Hyperscale data centers are massive facilities owned by companies like Google, Amazon, or Microsoft. These centers are built for maximum efficiency, automation, and scale. They host vast numbers of servers across multiple locations, supporting cloud services, AI application, and large-scale data processing. Hyperscale data centers now account for approximately 37% of the global data center capacity, up from just 10% in 2010. This shift towards more efficient, centralized models has helped reduce the average energy consumption per computing task. Nevertheless, the total electricity consumption of data centers has continued to grow, and quickly. So why does this matter? Let's look at some numbers. Data centers accounted for around the 1.5% of the world's electricity consumption in 2024, for 150 terawatt-hours. The United States accounted for the largest share of the global data center electricity consumption in 2024, around the 45%, followed by China and Europe. Globally, data center electricity consumption has grown by around 12% per year since 2017, more than 4 times faster than the rate of total electricity consumption. In terms of power drawing, a conventional data centers may be around 10 to 25 megawatt in size. A hyperscale AI-focused data centers can have a capacity of 100 megawatt or more, consuming as much electricity annually as 100,000 households. Historically, data centers have been highly concentrated on spatial terms. As a result, in regions where data centers are concentrated, the share of electricity demand going to data centers is disproportionately high. In Ireland, for example, data centers consume around 20% of the metered electricity supply. There are 6 states in the United States where data centers already consume over 10% of the electricity supply, with Virginia leading at 25%. This poses significant challenges to local grids, given by their substantial power draw. From an economic point of view, with the rise of AI and the constantly growing demand for digital services, global investment in data centers nearly doubled since 2022 and amounted for $500 billion in 2024. Data centers' electricity consumption is set to more than double, getting to around 945 terawatt-hour by 2030. This is slightly more than Japan's total electricity consumption today. AI is the most important driver of this growth, alongside growing demand for other digital services. The United States account for by far the largest share of this projected increase, followed by China. In the United States, data centers account for nearly half of electricity demand grown between now and 2030. That's why understanding the role of data centers is essential, not only from a digital point of view, but also from an environmental, social, and energy perspective. Their high and growing electricity consumption make them a key player in the global energy transition. Without effective energy efficiency strategies, data centers can pose several risks, significantly increasing greenhouse gases emissions or overloading electricity grids. Ensuring that data centers become more energy efficient is therefore crucial for responsible and sustainable digital development. In the next lesson, we'll go inside the data center. We'll break down its main components and learn where electricity is really being used.